Sure people will be showing up. People will be showing up over the next 5 minutes or so. It's an odd one that we are talking on Sunday because I guess one out of seven ought to be Sundays, but it just doesn't feel like we have that many Sunday ones. Anyway, we will eventually get around to welcoming our guest and doing the other program. But to start out first, let's, especially since the weather has been on everybody's mind, Bob, tell us what's the weather like where you are?
Well, this morning, very early in the AM, I actually looked up through my skylight in the kitchen and saw the full moon right up through it. There was a square of light on the ground, so it was very clear, and it's been bone chilling here.
Okay, as in how cold is bone
Uh,
chilling?
in single digit Fahrenheit.
Yeah,
Above or
my
below
mom
zero?
said it was 6 yesterday.
Ah,
Okay.
Minus
Margaret.
seven, minus 7 C is what it just got up to today.
Okay. And so, Margaret, you're not that far from Bob, so give us a little more about the weather in the area there.
Uh, every time I look outside, there's a little more white on the ground. It just hasn't seemed to stop snowing for a week.
Okay.
And yesterday it wasn't quite as chillingly cold. I mean, it was definitely as cold, but it didn't feel as bad as it had for the previous week or so.
Okay. Jim, tell us about the terrible weather you've been enduring.
Good morning. For a change, it's sunny, clear, and it will be 80 degrees at noon.
Where are you located?
I'm 30 miles north of downtown Phoenix.
Oh,
Okay. And Larry?
This is Larry Lebowski. I'm about 4 miles, 5 miles north of where Guy is right now, and probably, and actually, I don't know exactly where you live, Melissa.
I'm east of you about 3 miles.
Oh, okay. And so, but where a lot of astronomers live, and it's supposed to get up to 80 or 82, depending on which weather forecast you look at. And it's been clear, except the moon's been up.
Yeah,
Dennis. Oh,
so the telescopes that I use are on Kitt Peak, which is west southwest of Tucson, and I don't think we've gotten any snow this year. I think it's only been rain.
Dennis, where are you?
In Denver, where it's been warm and sunny for months. We're not really having a real winter. So for you folks in Arizona, what that means is there's not going to be much water coming down the Colorado River because we're at, I think, 59% of normal snowpack for this time right now.
Okay. Carmen, you're in the heat of the summer there. What's it
Yes,
like?
yes, it's wonderful. 32 centigrades, more or less, today. And well, I could see the moon yesterday, beautiful. I understand you call it a snow moon because of the
Mhm.
situations you are in, but I could call it a snow moon because it was very bright, very silver. Could see the
Ah,
mountains with my binoculars, of course, the mountains and some craters. But I also catch a satellite, the Orbcom, which is very important for my field work in connection with a legal paper. So it was great.
okay. Jeff, where are you?
I'm
You're
in Manorville, New York, on Long Island, and it's 14 degrees without the wind chill factor. Wind chill factor makes it 8 below 0. So Fahrenheit, which is pretty cold for
yeah,
around here.
especially for Long Island.
Yeah. So, but what are you going to do? That's the weather. Can't do much about it.
Right. Rosemary, where are you?
You're
I,
muted.
I had to unmute because I got a new puppy that decided wanted to chime in. I'm in Bayville, New Jersey, which is down the New Jersey shore. And it was 1 degree yesterday. Today we bit the bullet and didn't get that storm that's offshore, but we're a balmy right now. I just got back from Mass, 18 degrees. So, but clear. So hopefully the sun will melt some of this. We got a bad storm last Sunday that snowed. We got like 6 inches of snow, but then around 5 o'clock in the afternoon turned into a torrential rain and then plummeted to 15 degrees that night. So we're in an ice pack here. I mean,
Okay.
really ice pack.
Hope you didn't lose power.
No, thank God. Thank God.
Okay.
But I had
Phil.
Wally out on the deck still working.
Okay. Phil.
Yes, I'm in New Bern, North Carolina, which is about 40 miles from the coast, and we've had historical snowfall last night. Got about 18 inches in my yard, which is quite a lot since we don't get that much at all. And they called it a bomb cyclone, and it did look like a hurricane with snow.
Okay. I had a visitor this past week from my Peace Corps days who now lives. She was trying to describe where it was. She says, "You've never heard of it. It's a small town near New Bern." And I'm going, "I think I know where that is," because you guys had me out there a year ago. Pamela?
Good morning. I'm in Glendale, Arizona, very close to where Jim Wren is and very close to where Juan Pablo is. I'm in between. And it's going to be gorgeous today. By 1 o'clock, it's going to be in the 80s.
Excellent. Justin? Oh, you're muted.
Watertown, Connecticut, 6 degrees this morning. I'll see you in a month in New Haven, brother Guy.
That's right. I've been busy putting my travel plans together. Looking forward to seeing you. Fernando?
Yes, now. Good evening from Munich, Germany, where it's been a sunny day, quite cold, about 0 degrees centigrade here. And it's already in the nighttime and clear sky still. So hopefully it stays like that. It's been very wet in the last days or weeks, snow and rain alternating, very little sun.
Okay. JP?
Hello, everyone. Greetings from Phoenix, Arizona. It's 17 degrees Celsius right now. The high today is going to be 28 in Arizona. And the last thing I saw in the sky was basically the moon. I tried to catch JoJo or new nebula that Rosemary and I discovered at Acme, but couldn't find it. I guess the brightness of the moon is on the way.
Okay. Jeffrey?
Hi, can you hear me?
Yep.
Perfect. I'm Jeff. I live up in Edmonton, Alberta, Canada, and it's currently -4 here. We've got a warm snap, so the snow's starting to melt a little bit, so it's a good thing.
Okay. That's -4 Celsius.
It's -4 Celsius, that's correct.
Yeah.
Yep.
We have people as long as you're not giving us Rankine or Kelvin, then I think we're okay.
Or Kelvin, yeah.
Right. I had a class at MIT 50 years ago where they were describing temperatures and temperatures Rankine. And I had no idea what they talked about. It's the Fahrenheit version of Kelvin.
Yep.
I didn't know there was such a thing. Rob, you're a far distance from me. Tell us what the weather is there.
Yes, 70s and warm enough at night to do some stargazing. And last night, per the recommendation of Father Rich Boyle, I went and saw the star Canopus for the first time, which is kind of on the southern horizon here in Tucson. If you go a little bit further north, you can't see it.
Yes.
But he told me about it, and he calls it Obi-Wan Canopus, and it's his favorite star. So that
yeah,
was cool.
when Orion is very high up in the sky, it's just popping over the horizon.
Mm-hmm.
Very exciting. And Clark.
Well, I was out. It was nice and clear here. Saw the moon beautifully this morning, and over near Lansing, it was -10 or -23, depending on which units you want to use.
Great. And I have the last person who's listed as iPhone. If you're able to talk, let us know who you are and where you are.
Can you hear me?
Yes.
Okay, this is Billy Joe Gabriel in Fort Worth, Texas, and I live exactly 1 mile away from the Monte Meteorite Museum. So I'm a volunteer there, and it's so exciting to be there. Anyway,
I can imagine.
woke up, it's 20 degrees this morning. It's already warmed up to 34. The wind has shifted out of the south. It's going to be 54 this afternoon. So I'm glad for our bipolar weather here today.
Indeed. Great to talk to all you guys. I had mentioned that Paul Gabor, who usually gives us the report on the VAT, is actually in Safford, which is the town down the hill from the VAT, saying masses. The phrase in a community of priests is he's on supply, which I am told is the English version for substitute teachers. They're called supply teachers instead of substitutes. So that much of the phraseology has come through. Basically, though, I've been following the telescope reports. It is doing pretty well. We've got a new telescope schedule out. Larry, do you have anything you want to add that you know about the telescope and how it's been running?
Yeah, it was on the telescope early January and going up there again in 3 weeks, 2.5 weeks. And we had one really very good night. And then some white stuff was predicted for the second and third night. So we stayed up there the second night and came down before the white stuff started coming down. I think it's called snow.
Well, it's interesting. Of course, every telescope around Tucson's got or every mountain around every telescope has a mountain underneath it. I guess you could put it that way. Every mountain seems to have a telescope on top of it. And Mount Graham has gotten a lot of snow. But Melissa, you're saying, where's your telescope?
On Kit Peak. So it's only 6,800 feet. And we do usually get 1 or 2 snowstorms over the winter, but I think it's only been rain and mostly clouds, actually.
Okay. And
Yeah,
I know that.
Oh, sorry. I was going to say one more thing. The telescope is working extremely well. The Dawn system, the computer system is working well. And one of my associates has been working on automating the focusing and collimation, and it's coming along. So we're very happy.
One of the telescope-related big events that happened here is we have purchased a brand new 4-wheel drive vehicle that will get us from Tucson up the mountain. And if you think of it, it's no easy thing to put together because you've got to drive for about 2 hours on Interstate 10, where the average speed is probably 85. What the speed limit is 80 or 75, something like that.
Or 0.
Or 0, yes, depending on what part of I-10 you're on. And then you get to the mountain where you're doing 10 or 15 miles an hour up a really rugged dirt and sometimes snow-covered road for more than an hour. So the vehicle's got to be able to do both. And just this week, we've taken a delivery on a Toyota 4Runner hybrid, which we think will be able to handle both pretty well. So that's very exciting. And anyone who, wants to send us a check or two to help out the cost of the vehicle, we'll be happy to take it. It came under $50,000, but just barely under $50,000. Cars are not cheap anymore. And with that, we will switch over and I will now start with the introduction that we will use if and when we put this together as a podcast, depending on how busy Bob is putting podcasts together. Welcome, everybody. It's my delight to welcome Melissa Brucker to this version of the monthly Meetup. And Melissa is an astronomer here in Tucson who I first met when she was a grad student a few years ago, more than either of us want to admit, working at the University of Oklahoma and working with us observing trans-Neptunian objects. But since then, she's gotten involved with things that are smaller but closer. So Melissa, start out, welcome, and tell us where are you from and what's the science you do now?
I am from Brighton, Michigan originally. So I had been to the Cranbrook Museum and probably saw a guy's meteorite when I was little. Um, and now I work at the University of Arizona at the Lunar Planetary Lab, which is the university's planetary science department. And I am currently the PI of Spacewatch, which is a very long-running asteroid, near-Earth asteroid discovery, survey, and follow-up group. So we use two telescopes on Kitt Peak. One is the 104-ish-year-old 36-inch, which is the telescope that Lavinia Stewart gave the money to buy or to have created, to have built in the early 19 teens. And so this telescope that we use is the reason why Stewart Observatory, the astronomy department, is called Stewart Observatory. Yeah.
That's astonishing. I've just been involved in looking up the history of Mars observations because next year is the 150th anniversary of Schiaparelli thinking that he discovered canals on Mars. And how we wound up with an observatory here in Tucson is directly related to that. There was a guy named Douglas who was working for Percival Lowell, looked through the telescope and kept saying, I don't see canals. I think you're wrong. So Lowell fired him. He came down here, started an observatory, and Mrs. Stewart donated the money for that telescope that you're talking about. When did that telescope move up to from campus up to Kitt Peak? Do you know?
1962.
And there's another telescope in the same dome that used to be where that one was on campus, right?
Yes, yes. There's a smaller, newer telescope. In the building is still there. Right. It's almost in the middle of campus now, but when it was built, and it is in the same location, it was in a emu farm on campus, or right next to an emu farm.
I had no idea. What is it like to use a telescope that's 110 years old?
Well, only the tube and the gearing are 110 years old. We have the camera that we're using was built by my staff in 2002. It is has 4 CCDs in it, so 8 amplifiers to read out the images in a mosaic. And because we're not part of Stewart Observatory, we're part of the Lunar Planetary Lab. We are basically in charge of everything inside the building. And we do have another telescope. It's a 72-inch that was built from funds that our PI at the time had raised. And so we operate both of them simultaneously, but looking at different asteroids. So it doesn't, the telescope doesn't act like it's 104 years old.
That's lovely.
Yeah.
Well, tell us, what actually are you doing night by night? Are you just sort of saying, oh, I think I'll point in that direction and see if I see anything?
I mean, sort of, not really. So we are in the same department as the Catalina Sky Survey, and their telescopes are on the north side of Tucson, where ours are west-southwest of Tucson. So basically, globally speaking, we're in the same location. And they are a powerhouse in discovering new near-Earth asteroids. So we phased out of discovery by 2016, and what we are doing is we look at lists of near-Earth asteroids that are visible at the time and choose ones based on, we have like a prioritization schema of which kinds of asteroids near-Earth asteroids we want to look at. So we get a really long target list every night for each telescope, and then we can choose which ones we want to look at based on our prioritization schema. So in the winter, we can probably look at maybe like 8 to 10 asteroids per telescope, where we've been trying to push fainter. And so the fainter the object is, the more time we have to spend gathering light on it. So for what we're trying to do is get 2 to 3 measurements of the object's magnitude and its coordinates in the sky. And we submit those to the Minor Planet Center, which is the worldwide clearinghouse of a solar system moving objects. And so the goal is, with our measurements of the exact times and the exact coordinates of the objects, that our measurements will help the orbit computers, computing people, to refine the orbit. So the goal is to know where the asteroids will be for a very long time. And one of our highest priority objects that we look at are virtual impactors. And these are asteroids whose orbits are not well enough known so that there is at least one possibility in the next 100 years that it might hit Earth. The probability is extremely, extremely low, and no one needs to worry about them. But
And if you did worry about them, there's not a whole lot you could do.
well, that's why I'm wearing my DART shirt today.
So tell us about DART, and what would you do if something was about to be approaching?
Okay, so there are several possible ways theoretical ways that you could move an asteroid out of the path of Earth. And DART was a spacecraft mission, a NASA spacecraft mission, to send a small spacecraft and hit the moon of an asteroid. One of the reasons why I'm wearing the DART shirt is because my group actually discovered that asteroid, Didymos, the primary, and the moon, Dimorphos, was discovered by planetary radar. So we're very excited that the asteroid that they picked is one that we discovered.
When was that mission?
So that was 3 years ago now, 2.5 years ago. I have no sense of time.
Well, that's what happens when you're up all night. So
September
the idea...
26, 2022.
Okay.
Oh, very good. Thank you.
2.5 years.
So the thing that you're doing with your telescopes is to observe an asteroid that's already been observed.
Yes. Now, sometimes the ones we're observing were just discovered and may not actually be real. So we do the asteroids that are just discovered by the main discovery surveys, which the two most prolific are Catalina Sky Survey here in Tucson and Pan-STARRS in Hawaii. Atlas is also in Hawaii, and well, they now have some telescopes in other places as well, Chile and South Africa. And they also discover a lot of asteroids. So when the object is discovered, the survey will probably only take 4 snapshots of the sky. And so you would connect the dots to get an initial orbit for it. But sometimes there's noise in your image, or maybe one of the dots that you connected was a star. So the asteroid is not confirmed as real until after someone else or several someone else's have also observed that and sent in measurements on them.
It's a thing that I find fascinating that comes out of mathematics. If you're trying to know the exact motion and position and future of a body in motion where you know all the forces acting on it, you want to know where it is in X, Y, and Z space and how fast it's moving. So the speed in the X direction, the speed in the Y direction. So there's 6 different variables. Now you can convert them into 6 different variables, which are the 6 variables that describe an orbit. But when you look at the dot of light on your screen, you're only getting 2 numbers, the position maybe in declination and the position in right ascension, which means you have to observe it at least 3 times to get 3 sets of 2 numbers independent to get the 6 numbers. And if you could observe them perfectly, you'd be out of a job. but apparently you can't observe them perfectly.
So when I'm observing, I can't tell if the asteroid is big and far away or small and close because I'm only seeing the motion that's perpendicular.
And that means that you also can only measure its position to what kind of precision?
Ours is less than we would hope.
It's never as precise as you want.
So it depends on what size pixels your camera has. And like if the object is really bright, it could like spread out, the light can spread out over many pixels if the object is very bright. And it also depends on how good your clock is. You need to have the clock of the computer that is reading out the images from the camera has to have a very precise and accurate clock. And you also need to know exactly when your shutter opens and when your shutter closes. So right now we're actually working on the shutter closing time because we always thought it was correct until last month.
Until you discover that it isn't quite as correct as you hoped.
Yes.
Well, that's fascinating. So it does mean, and the point I'm really bringing to is something about science that a lot of the science fans get wrong and a lot of the science deniers get wrong. It's not perfect. It's really, really good, and we've got ways of making it better. But the whole joy of science is that you can correct imprecisions because you've got imprecisions that you need to correct.
And we have all of our data. Well, we don't have a lot of the late 1980s images because at that time they were using tapes and they would write over the tapes with the new data.
Oh no.
It's the 80s. But we do have all the rest of the images after they stopped using tapes. And storage media over time does degrade. So we have converted all of our old data to be on our network attached storage systems. So we can access all of the other images that we've taken, just not those first years that were on tapes. And I think it was just the 80s. So I think everything from the 90s is on current media.
Have you had to deal with glass plates?
No, I think that they had stopped using glass plates by the time our survey began. I'm sure that my retired boss has used them.
Right. We know about Chris Corbally here at the Vatican Observatory was talking about using them when he was a young astronomer back in the 60s. Just to throw in about tapes being covered, the Super Bowl's coming up this weekend. I don't know if you guys realize the original videotape of Super Bowl I was recorded over by something else because magnetic tape was expensive back in those days and nobody thought anyone would want a copy of it. It's kind of one of those astonishing data gets lost because, you know, it's just like the people in the old days had only so many manuscripts and they would scrape off the old writing and write new things on it. And only later do you try to figure out what was underneath the original scraping. Well, we talked a little bit about finding the asteroids and the work that you're doing now. But I'd like to go way back to your beginnings in Michigan. Tell me where you grew up, what was your family like, and how did you get involved in astronomy of all things?
So I grew up in Brighton, Michigan, which is in southeast Michigan. My dad was
Give us a little more detail of exactly where Brighton is, because I don't think a lot of people understand. And yeah, we're recording this by sound, so they can't see you pointing at your poem.
So if
What are the towns nearby?
So 30 miles north of Ann Arbor, about 45 miles from all the other cities that people who are not from Michigan know about, like Lansing, Flint, and Detroit. So kind of in the middle of all of those.
And it's famous for parks, as I recall.
Hmm.
So there are some nice parks in that area.
It's where the Astronomy at the Beach event is held.
Yes. I don't really live near there, but I
Okay.
have been to it once.
Okay. Anyway, what was your family doing that you were living in Brighton?
So my parents were both teachers. My dad taught at the Howell Public Schools. And my mom, so they met each other in Redford, which is a suburb of Detroit. They were both teaching at the same school. And when they got married, they moved out to the boonies at the time, which is Heartland. And so they were both teachers. And when my sister and I were born, my mom decided to be a stay-at-home mom for a while. But she was really interested in making sure that we got the very best education. So she went back to school and got her master's in gifted education and then forced our school district to have a gifted education program.
Excellent. Where did you go to college?
So I went to undergrad at Alma, Michigan, at Alma College in Alma, Michigan. It is in almost the geographical center of the Lower Peninsula. And it's about a half an hour south of Mount Pleasant, which is where Central Michigan University is. It's a very small school. When I was there, it was about 2,000 students. So a lot of my classmates had gone to high schools with a lot more students in them than college. And I wasn't really sure what I was going to do. So my bachelor's is in math, and then I graduated, and then I really didn't know what I was going to do.
Did you know Melissa Straight when you were there? She's a meteorite specialist who teaches there in the chemistry department.
Yes.
Or taught there. She's retired now.
I didn't know she was a meteorite person, but.
Oh, yeah. We've actually published papers together.
Nice.
Anyway, so how did you get out of the toils of math?
Well, I really like math, and I was very good at it. But the department was very small. I think there were 2 math professors and 2 computer science professors. And since it was so small, the computer science professor was too busy to actually learn the new languages like C++. So we got through and we made it. And then I wasn't sure what I was going to do, so I worked as a temp in an accounting office for 2 years. And then my mom got annoyed and said, go back to school or so I've been I was kind of like wandering through life at the time. And so I did go back to school. I decided that I wanted to go into astronomy, but in undergrad, I only had 1 physics class and no astronomy. So I enrolled at Eastern Michigan University, which is in Ypsilanti, which is kitty corner to Ann Arbor. So they're very close together. And Ann Arbor is where the University of Michigan is located. So I started taking classes and I took more and more classes. And my goal was to get all of the requisite classes in order to be able to apply to grad school. So I basically took the equivalent of an undergrad in physics and astronomy without getting a piece of paper for it. But because I had my transcripts, I was able to apply to grad school.
Okay, well, we'll stop before you even go that far, because you just sort of tossed off, well, I decided I'd go into astronomy. There's got to be a story behind that.
So my mom says that when I was little, I loved astronomy and I was like totally into it. And, we would try and go out and look at meteor showers, which we never could because we lived in Michigan and it's always cloudy. But I didn't really remember that very well. But I wanted to be in a field that I felt was exciting, but also I could lean on my background in math. And physics leans on your background in math heavily. So I really enjoyed taking classes there, and it did give me a really good foundation for applying to grad school.
So how did you find Oklahoma?
The guy I was dating got in there, not anywhere else.
I take it he's history at this point.
Yes. But it did turn out very well for me. I got to start working with Brother Guy.
So how did you wind up? Who did you wind up working with, and what was the project?
Okay, so I was working with Bill Romanishin. He was the one solar system professor at in the physics department at the time when I was there. And they did have a decent sized astronomy sub part of the physics department. So there were a lot of other astronomy people with astronomy focus, other grad students with astronomy focus in our department. Um,
The
and
thing that I had heard how Bill got into the solar system was he had actually started studying faint galaxies. And so he was an expert at knowing how to observe faint things. And then when the topic came up to do 22nd magnitude trans-Neptunian objects, he said, I know how to do that.
yeah. When I started working with him, he said, for galactic astronomers, asteroids are like the vermin of the sky. And now he was studying asteroids and the galaxies are the vermin of the sky.
I know this won't come through. I can't, sharing's not turned on just as well. There was a wonderful image we took when we were trying to observe Pholus, which is a centaur. And it's a very, very tiny dot of light that has first red, then green, then blue as we're shifting through the filters. And it's this tiny dot of light with, stars in the background and an enormous galaxy filling up most of the field of view. But the galaxy was boring. It was that little tiny dot of light because Pholus turns out to be a really interesting object that is halfway between a comet and an asteroid. It's called a centaur.
My group discovered Pholus.
Oh, excellent.
And Varuna.
Varuna, tell us about Varuna.
Ooh, I don't, sorry. Just a second, let me pull up Varuna.
Well, Varuna was for a while, I think, one of the largest, maybe the largest solar system object until small, right? Smaller than a planet. Bigger. I think it was approaching Pluto in size, but much larger than Ceres.
Yeah, it is 900 kilometers according to JPL.
Yeah.
And it rotates, I think for an object that size, it rotates pretty quickly. It's JPL says that its rotation to go all the way around once is 6.3 hours. So
which is very fast.
For an object that large is very fast.
And just remind us, how do you know, since it's only a dot of light, how do you know how fast it's spinning?
Oh, okay. Great question. When you're not sure if the object is rotating or in a way that's noticeable enough to you, what you can do is take a series of images over time. So the only time lag between each image is just the readout of your camera. So how fast your camera can collect the data after it's finished taking the picture. And so you would take a series of images, hopefully more than 4 hours if you can. So that depends on your weather and the moon and how long the object's going to be above the horizon and things like that. So you would take a lot, and usually short images, maybe like 30 seconds or a minute. And also the length of the exposure depends on how faint the object is. If the object is fainter, you'll need to take longer exposures. So you would have fewer total number of exposures, but ones that are longer. And after you have taken all of these images, you will measure the brightness of the object in every single image and then plot the brightness over time. And you should get, if the object is regular but oblong, you will get a sine curve like this.
When it's the flat side is facing you, it's brighter, and when the narrow side is facing you, then it's fainter.
Yeah, so yeah, the long side, it has more area to reflect the light off of, and the short side has less area, and so it looks brighter when the long side is facing you. And what you're actually seeing is sunlight reflected off the surface of the asteroid.
And the other cool thing is if you can do this at different places in its orbit, so you're seeing different aspects. So it's obviously not going to be, spinning exactly perpendicular to the direction you're looking at. And out of this, you can really come up with a very good model for the shape of the guy.
Yes, if you can observe that at several different times in the asteroid's year, you can get enough data to create a shape model. And a lot of planetary radar people work on the shape models. Unfortunately, Arecibo is not an asset anymore, but that was one of the big powerhouses for not only determining the shapes of asteroids, but also discovering their moons. It's very difficult to see the moons of near-Earth asteroids with optical telescopes just because the moons are so faint. But with radar, they broadcast the radio waves and they record the echo that bounces off the objects in the sky. And there are still planetary radar people working on this, so they use one of the Deep Space Network telescopes in California. So that is one of the radio telescopes that talks to all of NASA's spacecraft around the solar system. And I believe that there's still a radio telescope working on this in Australia. And there's Green Bank in Virginia.
Of course, trying to observe a body in different parts of its orbit when it's out beyond Neptune and its orbit takes several hundred years, that's a whole lot harder to do. But let's pull back. You're working as a graduate student. This is, we'll be honest, 20 years ago. You're at the University of Oklahoma. You finally get your degree. Then what happens?
Okay, well, before I got my degree, Roman was working with Brother Guy and Steve Teigler. And Steve Teigler was located at Northern Arizona University, which is in Flagstaff. And Steve Teigler had heard about a new program where Lowell Observatory would basically house grad students to work on their graduate thesis at Lowell Observatory with Lowell Observatory scientists. And that is where I worked on my dissertation, which got me to the outer solar system. Brother Guy and Bill Romanishin and Steve Teigler all worked on those centaurs and also Kuiper Belt objects out further out in the solar system. And so my dissertation was on trying to figure out, based on Spitzer infrared data of Kuiper Belt.
Spitzer was one of those satellites.
Yes, Spitzer Space Telescope was a satellite of Earth orbiting the Earth, but taking images of infrared objects, not only in our solar system, but also galaxies far, far away as well. And so what I worked on was I was given a lot of infrared data on these Kuiper Belt objects, and the programs that we used were to figure out, okay, how much the light that we see from them in visible light is the light reflected off the surface, and the light in infrared is the heat emitted from the surface. So those two different wavelengths are telling us about different things about the Kuiper Belt object. So if you compare how much the sunlight can reach it based on how far away the Kuiper Belt object is from the sun, then the light that is emitted and the light that is reflected should kind of add up to the amount of sunlight that reached it. Now, it's not the total amount because there's absorption and things on the surface. So what my job was to do is to figure out, based on the amount of sunlight reflected and the amount of sunlight emitted or re-emitted as heat, how dark is the surface? Because that is how the light is getting absorbed and emitted as heat. And so we found that, so before this study, a lot of people thought that because medium period comets, the ones that go through our solar system a couple times in history, these objects came from the same place where the Kuiper Belt objects are nearly the same place. And so everyone assumed that the reflectivity of the Kuiper Belt objects would be the same as the comets. And the comets are only 4% reflective. They're very, very dark. They're black, basically. However, the Kuiper Belt, we found in the study that I was working on with my colleagues, we found that the objects that are flat in the plane of the Kuiper Belt and not at an angle going through the Kuiper Belt are actually quite reflective. So instead of being 4% and very black, they were 10% reflective. And that means that the amount of mass that was estimated for the Kuiper Belt is actually less. Because these objects are more reflective, they're 10% reflective, then they're brighter than we thought they were, and therefore they are smaller than we thought they were.
Fabulous.
So that was at the time it was a really big conclusion, because now the Kuiper Belt was like 10% smaller in mass.
Oh my goodness. So you finished up this thesis. Now you've got to find a job.
I got to find a job. So I had an opportunity to apply for a job with the Herschel Space Telescope. It was a European space telescope, but it wasn't due to launch until June, and I was going to be done with my degree in July. And so the opportunity was not available to apply to until the successful launch. They did not want people to award jobs if the telescope
Wound
ended
up in the Atlantic.
Yeah, so I had an opportunity to apply for a job there, and I decided not to just because of the timing. I really wanted to get a job for the fall. And so I applied for a teaching job at the University of Nebraska-Lincoln, and I was there for several years teaching astronomy and algebra-based physics to the undergrad students there. And then after that, I moved on to Tucson briefly to network with all the planetary scientists that are here, since this is such a hotbed of planetary scientists. And I got a postdoc position at Adler Planetarium in Chicago. So Adler Planetarium was built in 1930. And Adler had heard about this fancy new Zeiss projector in Germany, and so he and his architect took a ship across the ocean to go check them out, and decided that yes, he's definitely wants one of those. And so he built a planetarium in Chicago. It's right on the shore of Lake Michigan. And funnily enough, it was because they at the time they built it, it was right before Pluto was discovered. So by the time it was mainly finished, there were 8 planets. And now it is the only historical planetarium with the right number of planets.
Well done. So how long were you there?
I was there, I think, for 3 years. Yeah, we had a 3-year grant.
Mm-hmm.
And so that is when I moved to the inner solar system. The person I was working with there was a near-Earth asteroid observationalist, and he
What was his name? Oh.
I'm sorry, I know his name, but whenever
Oh, whenever I do that, I'm sorry.
I do
I
know
always,
his name.
yeah, it'll come to you. Call me up at midnight tonight when you remember.
Okay.
Anyway, okay, you're working in the inner
Anyway,
solar
so
system.
I was working with them and another woman. We were both hired by him for his grant to do astrometry of faint near-Earth asteroids. And so we had so the grant that he had gave us a 1/6 share on the Apache Point Observatory 3.5-meter telescope. Apache Point is in New Mexico. The closest large town is Alamogordo, which is by the White Sands National Park. So it's up the mountain from where White Sands is located. And so we had a 1/6 share. So my colleague Christy and I would observe from 11 p.m. to 1 a.m. New Mexico time, basically almost every night. Or we'd have, however long, we didn't have all the nights, but we had that 1/6 share. And so we were mostly doing astrometry. So where the object is, measuring the coordinates and the times, just like I do now. And we also had a program to take spectra of some of the asteroids. So we would have like 1 or 2 half nights a month where we could spend that whole half night observing a particular asteroid. And so spectra is, instead of taking a picture in white light, invisible light, you are collecting all of the wavelengths, and so you will get like when you analyze it, you get more like of a pattern of how how bright the object is in each of the wavelengths in the band that you are looking at.
So you had 3 years doing that. And then
we needed a new grant, and our particular proposal was not accepted. So now that I was in the inner solar system, I wanted to find a job where I could still use telescopes a lot. And I had talked to one of my colleagues, Mike Nolan. He is a radar observer. And he and his wife, Ellen Howell, used to operate the planetary radar part of Arecibo. And I had interviewed with them a couple years before, so I knew them, and I had a meeting that I needed to attend in Tucson. And so while I was in Tucson, I like, hey, Mike, if you hear of any good job opportunities, can you let me know? And Spacewatch had posted, so several months later, Spacewatch posted that they were looking for an observer. And I'm like, great, I can operate telescopes. And I also applied for a job at the University of Hawaii, where for Pan-STARRS, which is the big discovery survey for solar system things in Hawaii. And I ended up taking the job here at the University of Arizona with Spacewatch.
What year was that?
2017.
Okay. So you come on board in 2017. You're now the PI of the whole project. When did that happen?
So I officially took over the grants in 2021.
Okay.
So there are right now there are 6 observers besides me. And then I was working for Bob McMillan, who has been at University of Arizona for about 50 years. He retired officially in 2019, but it's the emeritus kind of retiring where
So he's still here.
So you come to work every day anyway, even though you're retired.
We know a few people like that around here. So you're now settled in. You've got a pretty solid position. Do you see yourself staying here for a while?
Yes, I would like to stay here. It is about to be grant writing season, so we're hoping for
Okay.
yeah.
Well, we've been chatting away for about 40 minutes, which is great. I don't know if anybody here has questions you want to throw at Melissa. We've got a few minutes for that. Just a little bit about, her background, or when's the one that's going to kill us all going to be discovered? um, beyond
So
that,
I'll just cut that off right there. Statistically, we know where, based on population models of how many near-Earth asteroids we think exist and what their size ranges are, we know where 98% of the 1 kilometer and larger asteroids, near-Earth asteroids are. And I had mentioned earlier that our highest priority for observing are the potential impactors, but there are no known potential impactors that could possibly potentially impact us.
in the next
In
zillion
at least
years.
the next 100, at least the next 100 years.
Okay.
Calculates that for all near-Earth asteroids. And the only one, I think there are only 2 that are posted that go out further, or maybe just 1. Bennu is still on the list, but its next possible impact is much longer than 100 years from now. And the reason it's a special case is because we know so much about it. So I hadn't brought this up earlier, but asteroids, when the sunlight shines on them, just like here on Earth, it's usually the warmest in the afternoon, like around 3 o'clock. And it's the same for asteroids. The asteroid is rotating and the sunlight is shining on this side. And so when the asteroid rotates, that hot side is in a different direction. And that difference in the temperature as the heat is being emitted acts like a very tiny, tiny little thruster on the asteroid. And that little thruster of the heat being radiated away can very slightly move the asteroid closer to this, a little bit closer to the sun, or a little bit farther from the sun, depending on which direction it's rotating, if it's rotating clockwise versus counterclockwise. And so that's why Bennu is a very special case, because we know a bit. Yes, it's the York effect. Thank you, Bob, for putting that in the chat. So Bennu is a special case because we know a bit more about Bennu than quite a few other asteroids, in that we know about the strength of this York effect, or the Yarkovsky effect, on Bennu itself. And so we can calculate what that slow drift is for Bennu. And so we can calculate out more precisely or more accurately where it will be in a very long, in the long future, rather than the short.
I will point out that besides worrying about these things hitting us, it's good to know where they are if you ever want to go there and study them scientifically or exploit them for their minerals. So, of all the things in the world's most useless field called astronomy, you're actually doing something that could be potentially very useful.
There hasn't been much press about asteroid mining in the last couple of years, but 5 to 10 years ago, there were a lot of companies, startup companies, who wanted to do asteroid mining because they do have a lot of minerals in them that you might possibly want.
Including the water if you're actually out in space. We're running close to 11 o'clock here, and so it's time to wrap up. I'd like to thank you so much, Melissa, for being with us and sharing your time with us. And anybody, this is your last chance to throw a question or 2 at her.
Just
other than
one,
that, sure.
Melissa, anybody studying how to, if you will, deflect a potential dangerous asteroid that might be coming our way?
There are several theoretical ways. The only one that's been demonstrated was the DART mission, the actual impact. And I believe that would probably be the method that would be most likely to be used if there was an asteroid that may impact us that is large enough that needs to be deflected. Some other options could be painting one side of the asteroid white, so the Yarkovsky effect would work better, or attaching like thrusters to the side of the asteroid, turning it into a spacecraft. And in the chat, there are several deflection techniques that they have posted there. But I think the kinetic impact, which is what the DART mission did, would probably be the most likely way. And the European Space Agency has plans to build a spacecraft and have it in orbit, probably at one of the Lagrange points, so that if let's say a comet was coming from further out, they could deflect the comet with the spacecraft that they are building.
Thank you.
Okay, thanks. Thanks, everybody. Our next meetup will be on the 3rd of March. I look forward to seeing all of you there. And thanks again, Melissa, for your time with us. Take care, everybody.
If anyone has questions, feel free to forward them to me through Guy.
Okay.
Thank you.
Bye-bye.